Hello everyone, welcome to part 3 of Mechanical Metallurgy Gate Solution. Let us come to the sixth question. It is a continuous and aligned carbon fiber composite consists of 25 volume percent of fibers in an epoxy matrix. The Young's modulus of fiber and matrix respectively are, you can see EF equal to 250 GPa and EM equal to 2.5 GPa. If the composite is subjected to longitudinal loading, that is isostrain condition, and assuming elastic response, the fraction of the load borne by the reinforcement is. We have to answer given that it is the load is applied in isostrain condition, so we'll have to use equation which is valid in isostrain condition. So in isostrain condition, the elastic constant of composite is given as volume fraction of fiber into elastic modulus of fiber plus this is 1 minus Vf, that is equal to volume fraction of the matrix into elastic modulus of matrix. Now, or you can say this, since here isostrain condition is there, so the sigma of composite will be in fractional part which is borne by the fiber, and the some fraction will be borne by the matrix. So this is just for explanation purpose. Okay, now since stress is elastic modulus into strain, so we will try to calculate the stress which is borne by the fiber only. Now, so in the case of fiber, we can see here, in the case of fiber, this stress will be borne by the elastic modulus of fiber into strain which will be produced. So you know, now since this stress will be valid when there is a complete fiber, this is a complete fiber material, but since fiber is we have got only some volume percent, so this volume percent of fiber into the stress which will be carried, so volume percent into fiber into it is this is the strain. Okay, so this will come around 0.25 into 250 into strain. Okay, now for the same case in the matrix also, the stress will be borne the fraction of matrix which is present and the elastic modulus in and the strain, so this will come around 0.75 into 2.5 E. So because 25% is the volume fraction for fiber, so 75% will be volume fraction for matrix. Now, so the fraction of load by the reinforcement is what here? Fiber. So the load which is carried by fiber will be 0.25 into 250 strain divided by total load. Total load will be fiber load plus matrix load. So 0.25 into 250 plus 0.75 into 2.5. So this will come around 0.97. So this is the correct answer. So the answer will be 0.97. Okay. Okay guys, now let us come to the seventh question. So the seventh question here is, determine the correctness or otherwise of the following assertion and the reason. So the first assertion is, refractory BCC metals like tungsten and molybdenum are less ductile than FCC metals like nickel and platinum at room temperature. So this statement is correct here, because BCC metals like tungsten and molybdenum are relatively it's basically a stronger material as compared to FCC nickel, and these are stronger because stronger and since less ductile, less ductility is there. Now second, and the reason is the BCC metals have fewer independent slip systems than FCC metal. This statement is actually wrong, because if you see in case of BCC, the independent slip system we have got around 48. In the case of FCC it is 12. So now here there some confusion you might be having regarding independent slip system. What is the difference between independent and only the slip system? Basically all the slip systems which is present like the 48, these are the independent slip systems only. If you see in the case of FCC also, this is the total number of 12 slip system are the independent slip system only. But in the case of SCP, we have got 3 slip system, but independent slip system we have got only 2. So in the case of SCP there is some anomaly. Otherwise in the case of BCC and FCC, the independent slip systems are the total number of slip system. So this statement is wrong actually. So the correct reason is something else. So now coming to the options. So both A and R are true, and R is the correct reason for a wrong, because R is false. Both A and R are true, and R is this is also wrong. So both A and R are false. This is also wrong because A is true. Okay, A is true and R is false. Yeah, this is the correct answer. So A is true but R is false. To the last question of mechanical metallurgy. Yeah. Consider the following stress state imposed on a material. The stress is given as 90, 50, 0, 50 minus 20, 0, 0, 0, 140 MPa. So this is given in the matrix form. Okay. If the material responds elastically with a volumetric strain delta is equal to 3.5 into 10 power minus 4, what is its bulk modulus? So we know that bulk modulus is given as hydrostatic stress divided by the volumetric strain, or we say it that mean stress divided by the volumetric strain. So mean stress, sigma mean is given as, or the hydrostatic stress is given as sigma x plus sigma y plus sigma z by 3. So here, so from the table, from the matrix, sigma x is equal to 90, sigma y is equal to minus 20, and sigma z is equal to 140. So minus 20 plus 140 divided by 3. So this will come around 90 minus 20, 70, plus 140, 210 by 3 is equal to 70. Okay, so this will be 70 MPa. Now, okay, so bulk modulus equal to sigma m divided by delta, that is 70 divided by 3.5 into 10 power minus 4 is equal to 20 into 10 power minus plus 4. Okay, so this will come around 70. So this will be 70 MPa it is there, na? So 10 to the power 6. So 20 or 4 plus 6. So this is 20 into 10 to the power 10. That is equal to 200 GPa. So the answer of this is 200 GPa. So 200 GPa is the correct answer. Okay. Thank you. So I have identified total 8 questions in mechanical metallurgy. There may be some questions which are related to some physical metallurgy, mechanical metallurgy also. So in the next lessons, we will cover physical metallurgy, and then different questions will be covered. So okay, thank you.